Okay, happy non-class class, guys. Here we go. Let's figure out what we got happening here. So, I gave you homework on 7.1. It's on Canvas, and if you have any questions, you can come in and ask. Randy Bush is going to be doing our class on Wednesday. Okay, today I'm going to start 7.1 or 7.2, and then Randy on Wednesday will finish 7.2. Okay, and then no class, of course, Thursday, and then we've got break after that. Break the following week, and we'll come back after Thanksgiving and pick up at 7.3. Okay, now see, at this point I would say, you got any questions? And that's just not going to help if you start talking to your computer, phone, or whatever it is you're looking at this on. So we'll do the best we can with explaining this and trying to answer whatever questions I could foresee. Okay, so let's come up here and let's talk about what we're going to do today. Okay, we know about functions. Oh, pen's not get on there. I'm not sure. There we go. Functions. We can write them as in the form, like function notation, y equals f of x. Sometimes we say things like y equals x squared, or f of x equals 3x squared, or different things like that. Okay, so we've got these sorts of functions. We looked at f of x equals 2x to the third, f of x equals 1 over x, and so forth. Lots of different functions that we looked at. Today, we're going to look at a different kind of function. We're going to look at a set of functions that are called exponential functions. And we started them in 7.1. Okay, so if you're in class Thursday, then you are up to speed. If you weren't, then you might want to go back and look through 7.1 and then come back to the video here. So I am going to put us on hold, and I'll be right back. All right, back. Sorry about that. Had a little interruption here. Okay, this is very different than actually talking to students, talking in class to like live people, or doing homework problems, because I do these a lot for homework problems in my other classes, and that's different than a new lesson. So we'll just go for it. Okay, so exponential functions. Suppose I had this. Here's my example. Suppose you deposit $500 in an account that earns 4% interest each year. Okay, so how much will you have after 3 years? Oops, 2 years. Okay, we did this a little bit on Thursday. Let's take a look at this. Time, or years. And amount. So we're going to start at 0 years. You started with $500. After 1 year, we're going to add 4% to your account. So that'd be 500 times 1.04. Okay, so the 500 times 1 is the $500. The 500 times 0.04 is the interest, and so this adds them up. Then I'm going to take 4% of this amount. So the second year will be 500 times 1.04 times 1.04. The third year 500 times 1.04 to the third, and so forth. So you can kind of see the pattern. So after t years, you're going to have 500 times 1.04 to the t. So that would be my formula for the amount in my account is 500 times 1.04 to the t, where t equal years, a equals the amount in the account. Okay, so this is an example. This function right here is an example of an exponential function. So exponential function is one where the variable is in the exponent. Alright, so we got my variables in the exponent right there. And so we can examine these by, not examine, we can look at these by making a table, like we did here. Okay, we can graph them. We can look at, here's a graph. We're going to graph y equals 500 times 1.04 to the t. So if this is my y, this is my x, x is going to be in years. 1, 2, 3, 4, 5, 6. Well, let's just do this. T, y. So if t is 0, then we've got 500 times 1.04 to the 0. Remember, anything to the 0 power is 1. So that's 500. So we're just going to start here and go, there's 500. Okay. After 1 year, it's 500 times 1.04. I got a calculator here on the side. So I do this, so it's going to be 500 times 1.04. That'd be 520. So after 1 year, I'm going to go up here to 520. 20, 40, 60, 80, 600. So after 2 years, 1.04 to the second, it's going to be 520 times 1.04 is 540.8. So after the second year, it comes up to 540.8, so right about there. Now, this actually, which is hard to tell because of my scale, move that over a little bit, it's actually going to go like this. And it gets up, it just gets bigger and bigger and bigger. I mean, think if you just left this money in your account, it's just going to grow and grow and grow and grow. Now, what if, for instance, okay, this doesn't mirror real life, but what if I had a negative 1 in there? What would the graph look like? It'd be 500 according to the formula, 1.04 to the negative 1. Well, as you remember from exponents, that's 500 times 1 over 1.04, which is 500 divided by 1.04, which is 480.8. Okay, so I'm going to come over here and put that here at negative 1. 480.8 is going to be here. And so that curve is going to keep going down like that. Okay, so if I wanted to actually extend this out more, this just keeps getting lower and lower and lower. This keeps getting higher and higher and higher. Okay, so let's look at this in general. Okay, so I've got my equation, I've got my graph, or my table, my equation, and my graph of this specific exponential function. So let's look at a generic one, like y equals 2 times 3 to the x. Okay, this is an exponential equation because x is in the exponent, or the variable's in the exponent. And so let's make a table. Let's go with negative 2, negative 1, 0, 1, 2, 3. So this will be 2 times 3 to the negative second, 2 times 3 to the negative first, 2 times 3 to the 0, okay, that makes sense. I just plugged in my x values for x. So let's simplify these. This is 2 times 1 over 3 squared, which is 2 over 9, which is 0.2 if I round it. This is 2 times 1 over 3, which is 2/3, which is 0.67. 3 to the 0 is 1, so that's just 2. And then this is 2 times 3 is 6, 2 times 9 is 18, 3 times 3 times 3 is 20, 3 times 3 is 9, so 27, times 2 is 54. It gets big fast. Okay, so let's see if we can do something here to make this a little bit easier. Let's put a grid on here and then we'll graph this and see what it looks like. So if we do this, let's do 10, 20, 30, 40, 50, every other one. Oops. 10, 20, 30, 40, 50 should be up there. Oops. So there's 50, 60, and then we'll just do our regular scale, -1, -2, 1, 2. Okay, so -2 we have 0.2, so that's really, really little. -1 we have 2/3, a little bit bigger. 0 we have 2. 1 we have 6. 2 we have 18, and 3 we have 54. So 2 we have 18, 3 we're way up here at 54. You can see how this just gets really big really fast. Okay, so this goes up like that. This is why if you do that, take your penny a day, and double it. The problem we did in class the other day, you're making millions of dollars by like the 20th day or something. Now over here, this just keeps getting smaller and smaller and smaller. But you have to notice, it never gets to 0. Because if I plug in -10, then the y-coordinate would be 2 times 3 to the -10, which is 2 over 3 to the 10, which is really tiny. My calculator I don't think even does that. But I know it's a tiny, tiny number. So it's getting closer and closer to 0, but it's never going to touch it. Okay, this right here is called, as we talked before, an asymptote, because the graph gets closer and closer to it. And then this right here, okay, notice what that number is. That is this number right here. Because when you have 0, when you plug in 0, you get 3 to the 0, which is going to be 1 every time. So it's whatever this number is. That's just kind of the starting point if you want to think of it that way. Okay, so there's again, an equation of an exponential function, the table, and the graph. Okay, so let's kind of look at some of these here, see what we got. I've got some other things here. This is from the book. Okay, so an exponential function has this form. B has to be positive. Otherwise, we might take square roots of negative numbers, and that's no good. B can't be 1, otherwise it's just 1 to some power, which is doesn't change any. And A has to be not 0. Okay, so f of x equals 3 times 4 to the x. F of x equals 5 times 1/2 to the x. As long as that is positive, okay, and this is not equal to 0, because if it's equal to 0, that's terrible, okay, and this cannot be 1. Otherwise, it's 5 times 1 to the x, which is just 5 times 1, okay? So, and that's not an exponential, that's just a constant, right? If it was y equals, it'd be y equals 5. And that's not an exponential function, so we can't have that. Okay, so let's take a look at some graphs here. This is, I'm kind of keeping an eye on the time, I don't want to make this too long. Okay, so here's my function 2 to the x, and so I plug in values. If I plug in 0, there's 0, plug in 1, I get 2, right? I plug in 2, I get 4, and so forth. Plug in -1, and I get 2 to the -1, which is 1/2. See, these negative exponents are a big deal. Now, what happens here if I have 1/2 to the x? Okay, so if x is 1, then this is 1/2 to the first, which is 1/2. If x is 2, then it's 1/2 to the second power, which is 1/4. That's where this 1/4 comes from. Okay, if it's 3, it's 1/2 to the third, which is 1/8. Now what about the negatives? Let's plug in a -1. What's 1/2 to the -1? Well, you take the reciprocal, and that's 2/1, which is 2. Right? What happens when it's -2? We get 1/2 to the -2nd power is take the reciprocal, and you get 4. That's why that is. Okay, so notice the difference. This one is increasing, okay, if b is bigger than 1, right? Remember my equation, y equals ab to the x. And it's decreasing if b is less than 1, but of course b has to be bigger than 0. Okay, so as a general rule of thumb, if you just want to sketch y equals 1/3 to the x, then that's just going to be a decreasing exponential curve. If y is equal to 3 to the x, that's going to be an increasing exponential curve. Alright, does that make sense? I hope it makes sense. There's some other examples in the book. I want to see what we make sure that we got everything covered here, at least for the first half. Okay, so we're going to solve equations with exponents in class on Wednesday. So we're going to look at this. Well, actually, this is what you should do at home. I'll change up what I'm going to do here. This is in the activity book. Okay. So this just talks about exponential curves, making a table, and it asks you questions to do. So why don't you do activity 1, this will be your homework for Wednesday. Okay, to do activity 7.1, well, activity 1, okay, which is this whole page here, which is graphing, graphing it, y-intercepts, x-intercepts, things like that. And then activity 2, don't worry about activity 2. I'm going to have Randy Bush do that on Wednesday. So please come on Wednesday. I know it's tempting not to, but 7.2 we will finish. And I will tell Randy where you're at, where we're at, and what he needs to cover, and go from there. Okay? I hope this works out. Hope it helps you get through this a little bit. If you have any questions at all, ask Randy, and he will take care of you. Otherwise, have a great rest of the week and have a great vacation and enjoy Thanksgiving. We'll see you when you get back.